So we are taking up the second problem in Picard's method. Okay. So numerical method is that for solving the initial value problems of the differential equation of first order and first degree problems. Okay. So here, as we have discussed in the first problem also, the first video, if you have not seen, kindly see that video. In that I have explained the steps and we have solved one problem also in a detailed manner. Here we'll be going in a faster way. So here we have to do till third approximation. Okay, the question is given as third approximation. For the solution, this is a differential equation given and initial condition is also given. Hence find the y of 0.2 also they have mentioned. First we will find the y equation third approximation. Okay, so let us start with the differential equation. So y dy by dx is equal plus y is equal to e power x they have given, and from here see this particular part inside the function basically represent the x naught value which is 0, and outside RHS part represent the y naught value which is 1. Okay, that's the meaning of that. Now here coming back to this equation, here shift this y towards the right hand side. So everything should be towards the right hand side. Left hand side only the dy part should be there. So first I'll shift y towards right hand side. It will become then I am going to shift to what dx also. So this will become equation dy is equal to e power x minus y into dx. So first step is to LHS only should have dy, RHS whatever the other terms are there, and dx also will be there with that. Simple. Next, second step. Second step is to integrate LHS and RHS. Between we have to give the values, limits, lower limit and upper limit. Lower limit will be the LHS part. If you observe, it is dy. So y limits will be there. So y naught is sitting. So it will be y naught, which is 1, and the upper limit will remain y. Next, RHS will be between. RHS we know dx is there. So x limit will come x naught, which is 0, and the x value. So upper limit you can observe it will be x for the RHS side, and the LHS side upper limit will be y. Our equation becomes integration of dy. Here also integration of e power x minus y dx. Now LHS side, as we know, we have discussed, it is lower limit will be y naught, which is 1, upper limit will be y. Here lower limit is 0, upper limit. Okay, this you have to remember. Okay, very simple. Next, third step is to solve the left hand side which is having dy. That particular thing you have to solve. RHS part don't touch now. Okay, so dy. So as we know, if dy is sitting alone, I'll put 1 as the element, so there won't be any harm in the equation. So 1 integration with respect to y is nothing but y, and the upper limit and lower limit we have to put equal to RHS will remain as it is. Upper limit minus lower limit you have to do, so it will be y minus 1, upper limit minus lower limit in the sense in place of y I am going to substitute y, lower limit in place of y I am going to substitute y. That's why it is y minus 1. Okay. Now y you have to keep it on LHS side, rest all terms on RHS side. So I'll shift minus 1 to RHS. Whatever you are getting the equation y equal to something, that will be the equation we need. That will be the equation we have to consider. From this equation only we are going to form the first approximation, second as well as third. In the question they have said to find till third approximation, we are going to find till third. Let us start with the first approximation. So I have understood till the three steps only we had. Those three steps you have to remember. Okay. So RHS part we didn't touch. Integration we didn't do. So first approximation will start. First approximation, remember, whatever is there in the function x comma y, that means the function of x and y is there, this particular thing inside the integral. There you are going to substitute y is equal to what? Y naught. This is the, in the first approximation you have to substitute y as y naught only inside the integral part. RHS whatever is it is eating. RHS part there is one integral is there, right? That is nothing but the function of x and y. There you have to substitute y is equal to y naught. So the equation or the this particular thing becomes, see, y is sitting. No, here don't need to substitute. Remember, as I said, function of x and y you have to substitute what? Y is equal to y naught. Now y becomes what? Y1, because this is the first approximation. First approximation we have to find y1, second y2, like that. So y1 equal to 1 plus, now integration of 0 till x, e power x will remain as it is, minus, now here y is sitting, I have to substitute what? Y naught. Then you have to put dx. That's it. That's only the change is happening. So first approximation y equal to y naught, but in the function of x and y. Now what is the y naught value? We have just got to know that, we know that it is given in the question itself. We substituted, right? So y naught value is nothing but what? 1. So I am going to substitute here y naught value as 1. Now we are going to integrate and get the answer. Now what is the integration of e power x? As we know, e power x integration is e power x itself. No, minus 1 integration with respect to x is what? X. Now we have to substitute what? Upper limit minus lower limit. What will be upper limit minus lower limit? Let us now find out. So y1 value becomes 1 plus, now upper limit I substitute. In place of x I have to substitute what? X itself. So it becomes e power x minus lower limit. So put one bracket here, minus lower limit. In place of x I have to substitute 0. So it will be e power 0 minus 0. Okay, this is the part we have to do. Okay, done. Equal to what the answer you are getting? 1 as it is. Then e power x also as it is, minus x also as it is, minus e power 0 is what? 1. Okay, so it will be minus 1 because minus it is sitting here. Then minus 0 you leave it as it is. Okay, so this you are getting. Now 1 minus 1 will get cancelled. So what the answer you are getting? You are getting it as e power x minus x. So y1 value you are getting the first approximation value as e power x minus x. This you have to keep it. Okay. Now we are going forward second approximation. In second approximation what happens? Wherever the function of x and y, x comma y, that means function of x and y is there inside the integral, there you are going to substitute y as what? Y1. Now it is y1. Okay. So for the understanding purpose I will copy paste the equation because we need the equation also. So this is the equation we had. Now we are going to write the y as what? Y2, because it is second approximation. So y2 is equal to 1 plus. So inside the integral only there y will change. So here e power x minus, instead of y it will be y1. Okay. Now what is y1 value? It is not given in the question. Just now we found out using y naught the function of y1. This you have to substitute here. So that becomes 1 as it is plus integration of 0 to x e power x minus, be careful with minus n, minus y1 is there, minus of y1. The bracket is very important. Okay, just you have to understand. Power x minus e power x gets cancelled. So what is the remaining term? Okay, only x is remaining. Now we have to do the integration part. So y2 is equal to 1 plus. Now integration of x, we know it is x square by 2. See what formula we are applying, just remember this. If integration of n x power n dx is equal to what? X power n plus 1 by n plus 1. This particular formula just remember. Okay. Here it is power 1. So I have to substitute what? X power 2 by 2. Limit 0 to x. Now I have to put the limits. What happens? 1 plus upper limit is what? X. So if you substitute x, it will become x square by 2. Lower limit no need to substitute because minus 0 square by 2 is 0 itself, right? So only you have to substitute upper limit, it is x square by 2. Okay. Lower limit it becomes 0, that's why I am not substituting. So y2 value also you got. Let us go for the third approximation. In third approximation, remember function of x and y inside the integral part, okay, with dx. There you have to substitute y as what? y2. So in place of y, we are going to write y3 since we are going to find out what? Third approximation. So y3 equal to 1 plus integration of 0 to x e power x minus, in place of y I am going to substitute y2. y2, the previous one, this you have to substitute here. Now we have to do the integration part. So y3 becomes what? 1 plus integration of e power x is what? E power x itself minus. Now integration of 1 is x as we know, and minus 1 by 2 you keep it outside. Integration of x square is what? X cube by 3. Now we have to put limits also 0 to x. The simplified version of this becomes 1 plus e power x minus x cube by 6. Okay. Now upper limit minus lower limit you have to substitute. So here upper limit, lower limit also you have to substitute here. The problem here is that lower limit here, this becomes 0, this becomes 0. But here e power 0 becomes 1. So you have to substitute the lower limit also. Okay. So this becomes 1 as it is plus. Upper limit I will substitute, it is e power x minus x cube by 3 or 6 minus lower limit. Lower limit what happens? E power 0 minus 0 cube. No need to write there, I am just writing now. Okay. This particular. Now this and this is gone. E power 0 value is 1. Here minus is sitting, so it will become minus 1. So y3 value becomes 1 plus e power x minus x cube by 6. Here minus 1 is sitting, so minus and minus is gone. So what is the final value? E power x minus x is there, minus x cube by 6. This is the third approximation value. So this is the final required approximation, right? The third approximation, no need to combine now y1, y2, y3. Don't get confused here. There is no combination of all the things. We are not adding y equal to y1 plus that and all. y3 we got it from y1. y3 we got it from the previous allocated value y2, and y2 we got it from y1, and so on, right? So this is a combination, a chain we have created. So the y3 is combination already of what? y1, y2, everything. So no need to add and write the answer. Okay. So y3 is the third approximation. This is the final thing. Now they have asked you to find out y of 0.2 also. So y of 0.2, what is the meaning of this? Inside the bracket we have discussed that it will be the x term. Here in the question they will mention initial conditions, that's why we are taking x0. Here there is no x0, we have to consider it as what? X. So the value becomes whatever the third approximation is there, final value. In that, in place of x I have to substitute what? 0.2, that's it. So e power 0.2 minus 0.2 minus 0.2 cube by 6. So if you use the calculator and find out, it will be 1.02000694. So So this will be the final answer. Okay. So this is the final answer for the third approximation of the given differential equation, and this is the y of 0.2 value.